Hello, today we're going to look at some revision of our sets work that we have done before. So we're going to start off, here we have a Venn diagram, and down here we have another style of Venn diagram, so we're going to look at two of them. We're going to look at some of the sets notation that we know about, and we're also going to look at how we can translate into this kind of listing elements way of writing out a set. So let's start off with capital G. For the set G, we always use capital letters. So capital G is equal to, and then I have a curly bracket. Now a curly bracket can be written in two different ways. We can put a little kink in the middle of our bracket, or we can put a hoop in the middle of our bracket. But we must do one or the other. If we just put in a bracket like that, a square bracket, we'll lose marks. Even if everything else is correct, we must write a curly type bracket for our sets. So capital letter is equal to curly bracket, and then I have the elements of my set. The elements mean the members of my set, the members of my group, or the elements of my set. So commas in between each one of them. The reason is, if I didn't have a comma in here, did I mean that I had an element 8 and 9? Or do I have a single element, the number 89? So that's why we have to have a little comma in between each one of our elements to tell us that we're dealing with one thing and then another and then another. Now, often we will be given definitions of sets like this, and we'll have to translate into this list form. So let's start out by doing that. Capital F for set, is equal to even numbers from 1 to 10. I open up a curly bracket, and then I go, what are the even numbers from 1 to 10? I have 2, 4, 6, I'm putting a comma in between each of them, 8, and 10. So I'm saying that this is inclusive up to 10. The universe is all of the elements that could possibly come up in this question. So it must include the sets G and F. In this case it does. It has natural numbers that are less than or equal to, less than, so the smaller part is pointing towards here, so it's the natural numbers that are less than or equal to, our little bar down here, number 11. So that's going to be, open up a curly bracket, the natural numbers start at 1, and then 2, and 3, and 4, and 5, all the way up with a comma in between each, all the way up to 11. I include 11 because of the or equal to, the extra line underneath here. So that's my universe. That's all of the elements that can come up in any set in this question. This is my set F, this is my set G. Now how do I fill in a Venn diagram, this picture here? Well, what I'm going to do is always start at the center. And by that I mean this bit here. What is in both F and G? Everything in F and G has to be in the universe. We don't worry about the universe just yet. We start at the center in here, the intersection, the crossing over of G and F, or F and G. What is in both sets, G and F? So let's go to our lists and see what things are in common. So I have 5, 6, 8, and 9, and I have 2, 4, 6, 8, 10. So 5 isn't in both of them. 6 is in both of them. So I underline that. I'm going to underline the bits that are in both. 8 is in both of them. I'm going to underline the bits that are in both. 9 is not in both of them. So now I've got that, I'm going to fill in this part of the Venn diagram. I start at the center. So I'm going to put a dot in and say there's a 6. And a dot in and say there's an 8. I've put them in here because if we look at the circle F, that's everything that's inside the set F. Every number on this list here. And every number in G, every element in G, every number in this list must be inside the circle G. Well, if I have numbers that are in both lists, like 6 and 8, that means I have to put them, when I'm drawing my picture, my Venn diagram, I have to put them inside both circles. And I do that by putting them in where the circles intersect, where they overlap each other. Once I've filled this in, then I fill in the bit of G that only has parts of G in it. So I have 5 and 9 that are only in G. They're not in F as well. 5 and 9 are only in G. And then in F, 2, 4, and 10 are only in F. They're not in G as well. And I put in dots next to them. So I've now filled in G and F, but I still have to deal with the universe. So we're going to do very similar work here. We're going to look for what's already been covered. We're going to underline any number in our universe that's already gotten used up in G or F. And then we're going to put them, anything that's remaining, outside here. It's in the universe, it's in our big box for the universe, but it's not in G or F. So 1, well, actually, probably the best way to do it is to use the set. So 5 is used up, 6 is used up, 8 is used up, 9 is used up, 2 is used up, 4 is used up, 6 is used up, 8 is used up, 10 is used up. Now I'm going to write any number that I didn't underline out here. So it's in the universe, but it's not in G or F. So 1, 3, put a little dot under them as I use them up, 7, 11. Now I've completed my Venn diagram. Now that I've done that, life is very easy for these questions because I can just read off my picture. So Venn diagrams are very, very helpful for solving sets questions. So this is G union F. This looks a little bit like the universe symbol, but it does not mean the same thing. If it's a capital U off by itself, it means the universal set. If it's a U without any little tail down here, in between two other sets, it means union. I know it's not helpful that there are two things that look almost identical, but we can figure them out from context. There's no tail on this, and it is in between two sets. Now, what does union mean? Well, a union means everybody together. If we imagine a workers' union, it's all of the workers coming together for a common purpose. So a union is everybody. So G union F means absolutely any element in G and F, G or F. So I open up my curly brackets. This is a set. So I'm describing a group here. So this is going to be a set. So 5, 9, 6, 8, 2, 4, 10 are all in that group. Now you might have seen that in a different way. You might have maybe started in the middle and worked your way out. That's fine. The order of our elements does not matter in a set. We get full marks if we write it in any order we like, so long as it's got all of the right elements in it. The order of the set, the order of the elements does not matter. So that's fine if we wrote it in these numbers in a different order, so long as we have all of those numbers and only those numbers. Now, this reads as G intersection F. It looks a little bit like the letter N. So intersection is a word for where, say, roads cross over each other. So an intersection would be where two roads cross each other, and an intersection in sets is where our sets cross each other. Our circles are crossed over. So that's going to be for the elements 6 and 8. Open up a curly bracket, 6, and a comma, and 8. Now this next piece here means cardinal number. It means the number of elements in a set. So what is the cardinal number of G? I'm going to write that in for you. So this is the cardinal number of G, which is the number of elements in G. So we can go to our list or we can go to our picture. If they're inside the circle G, they're part of our list. So 5 and 9 and 6 and 8, all of those are inside the circle. So all of them are in the set G, and we can also go to our list to get that answer. So there's going to be 1, 2, 3, 4. 1, 2, 3, 4. And it's just a number. It literally means how many elements. So there's no curly brackets going on here because we're counting up a number of elements. It's not a set. It's not a group. Cardinal number of F. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. cardinal number of F union G. Well, we got F union G. There's 1, 2, 3, 4, 5, 6, 7. There's 7 elements in that. And we could also get that by going 1, 2, 3, 4, 5, 6, 7. All of the elements that are in F or G. Now, another bit of notation. Language. Is 1 an element of F? Is 1 an element of F? So element means is it a part of our group? Well, I can see here there's no 1 in that list. There's no 1 in my picture. So no is just my answer for that. Is this set, I can see it's a set because it has curly brackets around it, is the set 5 and 9 a subset of G? A subset is a set that contains some of the elements in G, and it can only contain stuff from G. So I go to my list or I go to my picture, and I can see, well, 5 and 9 is inside the circle G. All of the stuff mentioned is inside of G, so that means it's a subset. That's yes, it's a subgroup. It's a subset. So is it a group within our larger group? Say the boys or the girls in our class. So our class is our set, and the girls in our class could be the subset of that bigger set. So let's practice that again. Is 5 an element of U, U being the universal set? Yes, it is. So 5 is inside of G, but it is also a number in the universe. So yes. Is this thing a subset of F? This is the null set or the empty set, and by definition it is a subset of all sets, and that's just a fact we need to learn off by heart. The final piece here, this Venn diagram has all the elements listed out. Sometimes we will write out the cardinal numbers of elements in each part of a set, and that's what we're going to do now. So let's start in the center as we always do. How many elements? What is the cardinal number of the intersection here? It's 1, 2. There are 2 elements in that set, and I don't put a dot there because this is a cardinal number. It's not that the element 2 is in here, it's that there are 2 elements in this part of my set. And there are 2 elements in only G, and there are 1, 2, 3 elements in only F, and then there are 1, 2, 3, 4 elements outside of G and F that are in the universe. And in total, how many elements are there in the universe? There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 elements in the universe. How many elements are there in total in G? You can see I'm using square brackets this time for the number of elements in something. There's 4 total elements in G. We already found that out. And there are 2 and 3 is 5 total elements in F. Now, if we add up all of these numbers here, we have 2 plus 2 is 4, plus 3 is 7, plus 4 is 11. If we add up all of the numbers in our set, we have to get 11 because that's the number of elements in our universe. And that's all of the things that we need for now for revising sets.